So as soon as the oscillations are initiated, they will grow in size till the amplitude becomes not great enough to introduce non-linear effect, which reduce the amplification. So when the amplitude, see in the lab, we have done experiments using 50 millivolt as input. So in that case, if you give 50 millivolt as input to your amplifier, output is also properly amplified sine wave you got 6 volt, 7 volt output. But the same thing, if you give 6 volt, 7 volt as input to the amplifier itself, the output waveform, if you see, it will be clipped off. So you will not see some portion of sine wave, it will be cut off because of the non-linearity of the device. The non-linearity will reduce the amplification of the system. So it will have an upper bound over which amplification will not take place. So the same thing is happening here. So the noise signals are growing more and more, which will make your amplifier non-linear, which means that at one point the amplification becomes constant. It will not grow beyond a particular value. At that point, your oscillator becomes a source of sustained oscillation. There you see the equilibrium is established where the loop gain has become exactly equal to 1. A beta mod A beta is exactly equal to 1. So if there is no such limiting, if the BJT has not limited the amplitude of your growing noise signal, then it will go towards infinity and it will destroy your circuit completely. Since there is an inbuilt mechanism in bipolar junction transistors to limit the growing oscillations, this is going to be useful for us when we are going to have sustained oscillations coming out of your system.